Hello, this is MEI Further Maths Core Pure. We're in the first Sequences and Series section and on the fifth and final video on the method of differences. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. This is one of my favourite bits of AS Further Maths because it's really neat. I hope you'll agree with me. The method basically involves expressing the terms of a sum in such a way that huge chunks of the sum can be cancelled out in a nice regular pattern. The best way to introduce it is just to work through an example. So first of all, we're asked to show that this identity is true, and this is just a matter of simply adding algebraic fractions. Here we go. 1 over r minus 1 over r plus 1. Putting them over a common denominator of r plus 1. So I've multiplied the first one by r plus 1 and the second one by r, and that just gives me 1 over r plus 1. So we're asked now to find an expression for the sum from r equals 1 to n of 1 over r plus 1. So we've just shown that this is equal to the sum from r equals 1 to n of 1 over r minus 1 over r plus 1. We'll write out the first few terms of this. When r is 1, I've got 1 over 1, which is 1, take away 1 over 2, which is a half. When r is 2, I've got 1 over 2, take away 1 over 3. When r is 3, I've got 1 over 3, take away 1 over 4. And so on. We'll do the last couple of terms as well. If r is n minus 2, I've got 1 over n minus 2 minus 1 over 1 more than that, which is n minus 1. Then when r is n minus 1, I've got 1 over n minus 1 minus 1 over n. And finally, when r is n, I've got 1 over n minus 1 over n plus 1. You can see how I've set it out with the fractions that are the same as each other underneath each other. Here's a neater version. Now we can cancel out. The minus a half cancels with the plus a half. The minus a third cancels with the plus a third. The minus a quarter cancels with the plus a quarter, and so on. There'll be a plus a fifth underneath that minus a fifth. And as we reach the bottom, there'll be a 1 over n minus 1 above that 1 over n minus 1. And then minus 1 over n cancels with 1 over n. And we're just left with the 1 at the beginning and the minus 1 over n plus 1 at the end. All of the other terms have cancelled out. Here we go. That whole long sequence just reduced to 2 terms. That's what I meant about it being really neat. 1 is n plus 1 over n plus 1, so that just gives me n over n plus 1. Expressing the terms as a difference will often require the use of an algebraic identity. You won't have to memorise those, they'll always be given to you. And those identities can involve algebraic products, they might involve algebraic fractions, like the one we've just looked at, or they might involve factorial expressions. Here's another example. We're asked to simplify that expression, and the temptation is to multiply it out. But have a look at what we're aiming for. It's going to be much easier if we factorise. Both terms have an r plus 2 in them and an r plus 1. So if we take those out as factors, we've got that first term r plus 3, and in the second term we've just got r. And so the expression we're given is r plus 2 multiplied by r plus 1 multiplied by r plus 3 take away r, which is 3. So that means that this expression here is equal to 1/3 of the sum from r equals 1 to n of r plus 3 times r plus 2 times r plus 1 minus r plus 2 times r plus 1 times r. Now we've got our identity, we'll see where we get. You'll need to write out a few terms at the beginning of the sum to see what's happening with the pattern, and then a few terms at the end. With this one, the larger numbers come first, and so in order to be able to line it up, it's actually going to be easier if we look at it the other way round. So I'm going to rewrite this as 1/3 of the sum from r equals 1 to n of minus r plus 2 r plus 1 r plus r plus 3 r plus 2 r plus 1. Now let's start writing out terms. So that's 1/3 of, if r equals 1, then I've got 3 times 2 times 1. It's always best to write out the calculation rather than the answer, because you'll be able to see where the cancelling happens more easily. So that's minus plus 4 times 3 times 2. When r is 2, I've got minus 4 times 3 times 2 plus r is 2, 5 times 4 times 3. If r is 3, I've got minus 5 times 4 times 3 plus 6 times 5 times 4. That's enough to see what's going on. Let's go to the end. If r is n minus 2, then I've got minus n times n minus 1 times n minus 2 plus n plus 1 times n times n minus 1. If r is n minus 1, then I've got minus n plus 1 n minus 1 plus n plus 2 n plus 1 n. And finally, when r is n, I've got minus n plus 2 n plus 1 n plus n plus 3 n plus 2 n plus 1. And now we can cancel. So the plus 4 times 3 times 2 cancels with the minus 4 times 3 times 2. The plus 5 times 4 times 3 cancels with the minus 5 times 4 times 3. The plus 6 times 5 times 4 will cancel with a minus 1. And this term will cancel with the one before it. And finally, those two terms cancel, and these two terms cancel, leaving me with 1/3 of minus 6 plus n plus 3 n plus 2 n plus 1. All I need to do now is tidy that up. So that's 1/3 minus 6 plus n squared plus 5n plus 6 times n plus 1. And I'll need to move on to a new slide. That's where we've got to. Multiplying out the second bracket, collecting terms, and then taking out a factor of n to get my final answer. So the sum that I was given is equal to n over 3 multiplied by n squared plus 6n plus 11. Sometimes the examples will use factorials. Remember that 5 factorial is 5 times 4 times 3 times 2 times 1, so that n factorial is n multiplied by n minus 1 multiplied by n minus 2 multiplied by all the way down to 1. Pause the video for a moment while you think about the relationship between 6 factorial and 5 factorial. Okay, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So it's 6 times 5 factorial. So n plus 1 factorial is n plus 1 multiplied by n factorial. Okay, let's use this in an example. We're asked to show that r plus 1 factorial take away r factorial can be written as r times r factorial. So, r plus 1 factorial minus r factorial, using what we worked out on the previous slide, that's r plus 1 multiplied by r factorial minus r factorial. We'll take out the common factor of r factorial, and then we've got r plus 1 minus 1, which is just r factorial times r, or r times r factorial. We can now use that to find this sum. So that's equal to the sum from r equals 1 to n of r plus 1 factorial minus r factorial. I'll leave completing that one as an exercise for you. It's in the integral level 1 exercise anyway. There are more notes on integral on the method of differences. That's the end of this short video and the end of this set.